In episode 1, we tore down why traditional databases can't stop fraud in real time. Now we build the foundation. Everything else depends on the transaction event itself and a Kafka ingestion pipeline that can absorb thousands of events a second without dropping a single one. Before a line of rule logic, you design the event. This schema is load-bearing. Every window, every aggregate, every mitigation rule downstream reads these fields. Get it wrong, and every consumer pays. So you model for the questions you'll ask later. Who, how much, where, on what card, and exactly when. Here's our core transaction event. A stable event ID for idempotency. The card ID, which is critical, it's how we route and correlate amount and currency, the merchant and channel, geo-coordinates for location checks, and a millisecond timestamp because in fraud, ordering is everything. Producers, the point-of-sale terminals, the mobile app, the payments API publish events to a single Kafka topic. The trick is the partition key. We partition by card ID. That guarantees every event for a given card lands on the same partition in order. Our stream processors consume those partitions in parallel. Why does partitioning by card ID matter so much? 3 reasons. Ordering. A velocity attack only makes sense if events arrive in sequence. Parallelism. Thousands of cards spread across partitions and consumers, so throughput scales out. And isolation. One hot card never blocks another. This single decision is what lets the whole engine keep up. Next episode, we write the actual detection logic, sliding temporal windows in Flink that catch a card being used in 3 cities in 2 minutes while it's happening. See you there.